So we've had quite a variety of speakers in this morning session. Have there been many speakers coming to you here at the AA that are software designers? Has anyone ever actually? No, it's a pretty rare opportunity to actually see the different parts of the tools that you're using and thinking about how the tools you're using have been created, what the possibilities are for them, and to bring your feedback about how you're using them and what you'd like in the future. So, Simos, would you like to start us off? Do you have any comments or questions on what we've heard here?
Yes, I mean, I would have liked to see a bit more of these tools. Perhaps ask you whether we can borrow and test with our students. It is in this way that we have entered this. You know, we weren't expected as architects to be going into research in these areas. We were not. We are still considered to be marginals, perhaps eternal outsiders, incapable of doing rigorous stuff that is not just aesthetic. But I think we have proven in the last few years that we can be meaningful participants. And you know, sometimes in research in the past, people said, well, you know, you architects, what do you know about simulation? But then the design process is continuous simulation. And the architect can hold very abstract ideas in the mind, at the same time express them with a pencil, let's say now with a computer. And those expressions then can be translated into real objects. So we can move from very abstract to very concrete much faster and more effectively than anybody else. And therefore, you know, just to conclude now, we are the ideal simulators. And so please give us everything you've got.
Sure, but I won't give it to you as a tool that you can just use. No. Like Robert, I think I'll give it to you as a research vehicle so we can work on it together. So I completely agree. And in fact, for simulation to become a design tool, it has to be used by designers. So, and this is the part where we need to move simulation from the engineers using the simulations or creating simulations to the designer creating simulations, and hopefully not as a separate thing, like I'm a designer now creating the simulation, but I'm a designer, I'm designing the simulation. So I agree that for this to be effective, it has to be collaboration in that way. So,
yeah, I think that's what your statement, like, you know, we're designing things which I think are hybrid because they combine aesthetic and cultural value judgments with engineering systems. I think that's why it's one of the fascinating things about taking architect and engineering as the subject for our software development, because you are not just doing banking simulation or airline ticket booking systems or something. There is this very interesting mix of ideas that we as software developers have to respond to and create tools that work for a very broad range of ideas and aspirations, and yet end up with a result which is a physically realizable building. So I think that's one of the interesting things is also that the idea that although in a kind of university setting, a school setting, you can say to your students, well, if you sign up for this class, then, or this program, then you will have to do these things in order to graduate. You will have to learn how to write a program, for example, or you have to learn how to design a building, or you have to do these different things. And so there's a sense of a pre-agreed contract between what the student, what the director of the studies is saying, and what the student has to do. And so that the comment that I made about, every time you introduce a new abstraction, you lose half the audience, is a different kind of situation when we're writing software which we want to use in a university setting, where you have this kind of contract and obligation between the course director and the students. But we also, of course, want to write software which is used in a professional situation where, well, I'm designing this building. If I don't understand the software, I'm just not going to use it. I've got to get on and design this building. So we have a different kind of situation there where we have to somehow give some, there's an investment cost. The user is saying, I'm prepared to spend some time learning how to use the software, provided the software is immediately giving me back some benefit. And then on the basis of I got a little bit of benefit, then I'll make another little bit of investment in learning more about the software. So that's a different, that's a different kind of model. We're trying to write software, if you like, that addresses both a sort of a formal pedagogic approach, where you can say to your students, I am taking you on a journey over this whole year's program, and at the end you will see why I introduced these abstractions or these concepts early on. It will all come together, where we don't quite necessarily have that luxury when we're writing software for practitioners, where essentially whether it's a computing concept that has to be introduced or an ecological concept that has to be introduced, these are things that most probably they haven't previously discovered or haven't been exposed to. So it does raise some very interesting challenges, and I think the way we kind of the way I'm going to address this is like sort of progressively revealing the underlying complexity. Like you can do something at a kind of graph node diagram, like the grass, general component set in Grasshopper has it, Azam was just showing it. But okay, I want to go. How do I go? Yes, I can diagram this. I can generate some geometry. How do I kind of peel that interface, that very intuitive interface back, and see the actual source code underneath, or get deeper into the logic? So there's some really fascinating user interaction issues here as well, of which Azam and the Autodesk research group in Toronto are, that's another area of their interest. So there's multiple layers here of you are outwardly directed, you're solving your architecture and engineering problem. You present us as very interesting, if you like, clients or users or target audience for our thinking, and we're designing our system to support what you're doing, bearing in mind that you represent a range of interests from purely visually or spatially creative through to something which is very engineering and a one dimension, and you may not initially be interested in computation or logic or abstractions, but how can we engage you in that more computational direction at the same time?
Just something else which I would like to raise with you, which I find extremely important for me. And the first time I engaged with thermal simulation and 3D computation was in 1980 with my Apple II computer. This is quite some time. And one of the things that I found is very interesting is that simulation is a learning tool within the limitations, that is, of the kind of processes that you can simulate. You're learning by doing it. Now, the corollary of this is that as you're learning, you need it less to some extent, because, like with music, where you have a limited number of notes, the palette of architectural interventions that make the building independent from mechanical systems is also limited. There is infinite expressions, but so once we understand what the shading device and so forth does, and we know the range of shading devices, and we can position them properly, then, so one thing that has been absent in all software has been the ability for them to learn. So that as the user learns, then they do not necessarily need the whole gamut. They want to approach faster That's something interesting, I think. And in fact, we've had a PhD who took up Ecotech and wanted to see how a user might make it more user-friendly, so to speak, despite the fact that Andrew Marsh, by definition, had made it as user-friendly as anybody had ever made a piece of software. But it goes to show that once you start repeatedly using, there is a process that's taking place which does not want you to go to the full range and want to simplify, so that and at the same time, well, it's like collecting an expert system out of the runs that you've done, which I think is fascinating, and I would like to put it forward as something to consider. There's no simulation tool that we're using of any of the many that does that, even comes close. In fact, the user interfaces are usually limited, and the help routines are appallingly, in between something. They're not too technical, they're not too clear, and that's another area in which I think...
Well, I think maybe if you're like somebody like Andrew Marsh or a software developer, you set yourself a particular challenge to present a set of calculations in a user-friendly way. And Andrew's a really great guy, incredibly enthusiastic and talented. But I know from my experience that, my God, that challenge is so imposing on one's thought process that one is really happy if one actually ends up with an application that somebody else can use, which does perform the calculations and exposes those calculations to the target user in a reasonably usable way. So everybody has that challenge. What you're introducing really is the second dimension, which is, no, it's not a single user with a single set of skills. It's a user who may be progressing in skill and whose use of the system is actually contributing to that progression. Or it may be, in a more collaborative design scenario, a number of people at different levels of skill who wish to use the software essentially as some intermediary, as I was saying, in some decision-making process. So we're just grateful that we got something working. Okay, well, now we've got something working. Now we can think about the second dimension of, well, how do we make it more adaptable? How do we allow the user to be part of the user's learning experience? How can he reconfigure it or tailor it so it's not imposing what it had to impose before, because you are now saying, oh, I know which way this. I know I'm not going to put the shading device on the north face, so don't worry about it.
I would say also that that's not unique to simulation software. So all software has this issue. This is a general human-computer interaction issue that, in fact, our research group has also taken this as a topic of learning large, complex software systems. And so George Fitzmaurice in our group is leading that effort of looking at how people learn these systems, but also how these systems can then progressively reveal what other people in the community have done with these tools, including your own community, and other recommender system type things that can possibly help you explore different parts of the program or reflect your own usage of what you yourself have done with it. So it's a very interesting area. There's a few things that have come out of that research so far, but there's definitely more to do.
Is it worth clarifying that Andrew Marsh is an architect and an author of Ecotech software?
I mean,
everyone knows it, okay.
But there's no, we should bring the audience in, but maybe we are helping to bring them in.
I think so.
And that we're giving them time to reflect. When you brought this combination of inputs and modules for the system design devs, and then the Met Office and MIT and so forth, various experts can contribute, because we need models for this for these modules, and we need input data. And I was alluding to this, that reliable input data are hard to find. And thankfully in simulation we have the thing called sensitivity studies, in the sense that you can posit a range and you can run for the extremes, and then if the difference is very small, you know that you're not in danger of going too wrong. But if the difference is huge, as it could well be, then what? Then you need more reliable data. And so where you find the data, and again the way in which the data come into the system and contribute to its learning, so that you know this set of data after trial and error or from a better expert source, you know, has consolidated. I think that is very important. It is absent from the software, you know, in its generation, but can be given, or the user can be helped to incorporate it, you know, as in fact it does. And the other thing that has happened, of which I have good experience, is how if you run lots of simulations, say hundreds or thousands, then you can correlate them. You can establish mathematical correlations. This has been done a great deal, and I showed, in fact, some progression which was correlatable, had been correlated by the students, and gave a linear progression, because we know that changes in that particular variable, in this case a cool climate, change in the heat loss rate then has a linear correlation with the mechanical space heating up. And I think that is very helpful because it avoids stupid simulations, you know, so that all the simulations that you run have a meaning, have some thought behind them, rather than stupidly running, you know, all values of parameters, which is another interesting in the learning process.
That's the other type of learning. Is it'd be nice for, of course, students to learn, but also it'd be nice for the software to learn. What is a useful as part of a sensitivity analysis, but also in general, learning what in a similar way to a recommender system, recommending to itself what parameters have what general purpose and result.
Well, you see here I can see about 50 people, 50 of my current or ex-students, all of whom have been exposed to simulation. You know, they're all users. In fact, they're much better users than I am on the software. They have critical interpretation. They have excellent mechanical skills. And maybe they have questions or comments.
Do we have a microphone? Thanks.
Hi, my name's David. I'm a PhD student in somewhere between architecture and computation, and I think my question is primarily to you, but all of you probably have an input on it. And you talk about this discussion of really integrating a lot of different simulation tools with the design tools themselves, about users starting to not just use the software and programming things, but actually inputting into them and developing their own tools. And that's very close to my own interest, and I think it's a very good kind of endeavor to take on and something very necessary. But I also get a bit, how do you see that happening within the current kind of proprietary software paradigm? And I'm not necessarily advocating, you know, completely open source or, you know, Autodesk should give up its revenue, of course, but it feels to me that if you're really expecting this kind of really integrated approach to work, you need to have open format sharing, you have file formats, you need to have, you know, enable different fabrication methods, different design methods to really feed back and forth to each other all the time. And how can you make that happen? How is that possible? For a company, you know, how do you relate to that as a company like Autodesk?
Well, I'm in a nice position in some ways, in that I'm in the research group. So it's an industrial research group at Autodesk. So we're not tied to any product group or any revenue source and things like that. So we're funded to explore real academic research. We publish papers. We review conference papers and journal papers. We create symposia and participate really in the research community. So that's the first level of freedom we have to create some of these systems to think about some of these ideas. And so the design devs idea itself, I've conceived of it as being an open API. And by that I mean, it's true that if we're going to be successful with something like this, and I want to have academia, government, and industry contributing to this, that will only work if it is, I believe, I agree with you, that it'll only work as an open system. And in fact, open from both sides of the API, so that industry or academics can create, let's say, plugins, but like models from the top, but also the simulator at the bottom can also be created by multiple people, including academia, government, and industry. So the way for, I think, a corporation to be involved in that sense of helping to achieve that vision is, I'm hoping that I can leverage Autodesk's weight in this area to encourage people to develop to that API, that open API from both sides. So the other nice thing about this devs formalism thing is that it does support this distributed and parallel sense, so that some of these nodes, although they look like nodes in a grasshopper way, they're actually not. Each node is a different program that can be run on a different computer in the network, on not even the local network, on the internet. So many parts of the simulation might not actually run on an Autodesk computer. It could be running on some proprietary person's computer, especially a company, if they don't want to share their secret way of doing their material change or some device that they have in the building. They could run that part of the simulation on their own system, within their own firewall, and so on. So I have tried to consider the openness in proposing such a system, if that answers the question.
Yeah. So I think I'm sort of closer to the kind of commercial environment than Azam. So yeah, I mean, from the design script perspective, we have a number of levels of open sourceness or extensibility. I mean, that's absolutely key. That we don't want to be the bottleneck to say, okay, I can't design this building because you haven't provided me with a module that does dormer windows or something. Oh no, hang on a second, guys, we're no longer in that situation where the user has to wait for the software vendor, to put a particular feature in. And it may not be economic. You may be doing some very original building that has your originality in it, which how can I describe this? You don't want that button on the menu for everybody else to use. You want that to be your button, okay? And it's such a specialized thing that it's not worth our while making that a general feature. So we've stepped back from saying, okay, we're going to provide every kind of wall, window, and door. No. We're going to provide a programming environment. And if you want that wall, window, or door, you can write it yourself. But you can embed your own knowledge or specialized functionality into that. So in a design script level, you'll be able to make your own design script classes which will represent particular components and trade them with other people if you wanted to. In fact, we've already worked with Bureau Hapo to embed their smart form finding functionality into design script, also robot and ecotech. Mm-hmm. So these were just like three. We just took the language and said, let us make a special class to handle robot nodes and beams and columns, or smart form, or ecotech polygons, so a sun position. So we're proving that with Bureau Hapo being the kind of surrogate third party. Okay, we're writing this software. How would you get on writing a plugin for us? But then, as I kind of explained in my presentation briefly, that design script is a multi-paradigm language. Okay, so at that level, if you have another language, and Lua most probably will be our next candidate language, you could plug in another language into the design script framework. Okay, so that's really, we will provide an API which said, if you want your language to be plugged in, it must, behave. When we say your function is going to be called, you need to go and execute your function and return this result. Okay, so if you're if we were in like a computer science department, that might be a very interesting next level up. Okay, how do I plug in different kinds of languages so that I can embed one language in the other? I can have some out of for loop doing some optimization, which is in turn driving, I don't know, some Prolog or Euler or something function inside that loop. And then, ultimately, maybe it's open source in terms of inviting people as equivalent to what Azam said, to actually contribute solvers or compilers and things to the actual system. So I think that those languages and those systems that have been open source take off because they provide a kind of infrastructure. To use some kind of like architectural expression, they provide an infrastructure, and then they become an ecosystem of lots of different plugins. And of course, the more you have, the more they complement each other. So I don't think there's any. We're interfacing to languages like C#. You've got to have a C# class you'll be able to directly call from design script. So that's a kind of completely open system. So the idea of proprietary languages or systems, I think, is really sort of passé. What I would say is that we're doing a lot of very complicated geometry modeling, and we're harnessing the Autodesk Shape Manager to do all that solid modeling. I think what are you interested in? Are you interested in designing a building, or interested in making a solid model account? Okay, because my assumption is that at this level, you are interested in providing the top layer of logic, which represents your domain interests, and within that domain, your particular project interests. You're not interested in writing compilers or simulation kernels or solid modeling kernels. But if you were, we'd still be interested in talking to you. There's many different levels of which one could contribute to these systems.
You've probably covered it in your thesis, but I think part of the issues that Simos raised earlier also come from this current method of not acknowledging the ecosystem of software components that could work together, that currently as not integrated systems create some of these barriers.
Doesn't it apply to the design devs that the separate systems there representing, modeling aspects which in fact interact?
No, that's, I don't mean to claim that it's easy. Just by composing them doesn't mean that they work together. Because the foundation is really about how to have things interoperate, there's a hope that we could have, this is not just my goal, this is the goal of many people who are trying to have integrated simulations, is to have the CFD affect the structural simulation, affect the thermodynamics and these things. So I have some thoughts on how we're going to do this, how we're going to try to do this, and but I am optimistic that we can actually create a system where these components, although they're being given their time slices to work, that they will be able to communicate these results. Now, communicating the results also is not non-trivial in the sense that they're sharing large data sets and this and that. So when you mentioned, I think you mentioned file formats, open file formats, that's problematic in the sense that files are problematic. So I think another dimension we haven't really talked about is scale of dealing with these kind of large data sets that need to be coordinated when you're having a bunch of solvers look at the same data set, common data set.
See, one other aspect which is preoccupying us a lot is that thermal simulation introduces time, and this is great because time did not exist, for the architect in other ways other than very artificially. Okay, I mean, it is abstracted time, but it is time nonetheless hourly. But thermal simulation has lost space in replacing it with an abstract point in space. At the center of the room we have an abstract point for which we predict the temperature. And around the room we have surfaces for which we predict the temperature somewhere on an abstract point of the surfaces. So we've lost space. And this is a huge problem. And when we simulate for light, for daylighting, then we have space, we lost time. And so, and one of the key problems for the combination, because if you're using artificial lighting, then you're adding to the cooling loads. Mm-hmm. If you're using daylighting, you reduce that and you also change the quality. So that when you're running a thermal simulation, you would have insisted, as an engineer, as an architect, as a physicist, that both are run at the same time. They don't. It's a key problem. It's more fundamental than that losing the CFD and the thermal, not running at the same time, because that can be fudged much more easily. But this relationship, that is key. You would have wanted it to run in parallel. So there are interesting things which I think only you as software developers can actually somehow make happen, or some huge engineering office.
Well, I think this is maybe relating to the methods of reduction that I mentioned, like the problem with dumbing down the system to be a single point in the center of the space is, I think it's an artifact of the old way of doing it, and I don't think we need to do that. I think it just actually introduces a set of problems that make it difficult to deal with that, and we really just need to go back and fix that.
Yeah, you're absolutely right. I think we're using, as you said, I think we're using models that were programmed maybe 30, 40 years ago, where the mainframes took the whole plan of the building, and then if you wanted to translate that for some more manageable computer, then it had to be simplified considerably. And also I think this is perhaps crucial, that they were intended for engineers, not for architects, so that the abstract point is fine for them and the surfaces. Whereas for us, I mean, this is where we are. They are there. We have different environmental conditions there than we have here. And we do want for each individual to be able to be catered for, provided we can predict what will happen to them. See, you had a model, for example, for your occupant, and you had moved your occupant to the left of the section, close to the window. He or she was going to open a window or operate a blind, and then perhaps move away from that somewhere else. As a result of this movement, the somewhere else would have acquired different conditions, which we want to know. Was the occupant, after this adaptive opportunity was taken, was made more comfortable, or would he or she go back to do something else? Mm-hmm.
Yeah. And even worse is that there might be now these conflicting things where there's heating happening together with cooling and together with light and then comfort.
Cooling there because it's more dense, heating here because it's close to the window.
Quite interesting is that though the audience might criticize sometimes the usability of design software, we have this very strong theme in Autodesk called user experience. Okay, so we actually put people in a lab and we observe them, using our software, and we try to make the user experience something which is very positive. And you've just raised, I think, a very interesting question, which I'm not quite sure how prevalent it is in architecture, but the building user experience. How are you? What you're describing is the person gets up from their desk. Their conditions at their desk are not what they desire. They go and modify some part of the system, okay, and so they experience something locally. When they're doing that, they now come back to their desk. Has that actually changed their condition? So I think there's tremendous opportunity, and I'd be very interested to know whether you're doing that, or if anybody's doing that. Is anybody doing the equivalent kind of user experience research that the software industry is doing on building users? Because that seems to be the next one of the challenges. We can do all the ecotext and all the calculations. If we want to engage with the building user as part of the total system, then we need to do this research. I guess, is anybody doing that in any school of architecture that you know of?
Well, we try to do this all the time, but we don't necessarily have the means of doing it. To instrumentalize it so that it's part of our computation, let's say.
Because I think that's absolutely critical.
CFD can do that, but it's so slow to run that you abandon straight away, because if it will take me a split second to move from here to there, but it will take overnight to run the two.
Yeah, but I'm talking more about observational studies of people in buildings of different, like, do I have a thermostat on the wall that I can change? Do I have a window that I can open? Do I have a blind that I can extend?
Well, this is the mapping. The mapping.
I think it's really so.
Let me take a comment here.
I'm a research student from the Royal College of Art, actually, and I'm doing research into user misbehaviour in a sense, which is really looking at why do people switch on lights and open windows, and it's not always because they actually want more light or because they want air. There are other reasons behind taking those actions, and I'm trying to sort of map those onto what we try to do with the sort of building service engineering, and sort of see where those inconsistencies lie and where the design opportunities are. And I mean, I guess my point and my question is, where are the opportunities for misusing the software? Okay, can you hear me okay? If I
Yes, it was fine, but maybe the recording isn't.
I'm kind of interested in how you misuse opportunities for misusing software, and it reminds me of a little kit of parts that was prototyped recently that allows kids to plug Lego into Connects or stickle bricks, and it's just a very simple kit of parts, universal adapter, that allows kids to kind of imagine what it's like to play with Meccano alongside stickle bricks or something like that. And I wonder if there's any kind of opportunity for allowing that misuse of the softwares.
I think it happens all the time.
That's the most common use, is the misuse, right? I don't think I understand what that you want to encourage that or discourage that. I'm not sure.
I think, in a way, try and understand it, because I think the usual response is if something is being misused is then the designers have to try and work out how to stop the user from misusing it, or they make the control even more sophisticated. But I think there's kind of, things will always be misused, so maybe there's a different opportunity by looking at what is generated by misuse.
So the example would be, I open the window and I turn the air conditioning down. So I'm doing something self-defeating. I have actually, haven't got an integrated strategy. How do we explain to somebody? We're just talking about this at coffee. Maybe a way of doing it is, in the hybrid cars, you have that meter which tells you, are you taking energy out of the battery, or is the engine started and you're generating electricity? You need some kind of meter. So when the user does open the window and then turn on the air conditioning, they can see, okay, this is the effect I'm having. Is it worth is my comfort worth the money that it's costing me? Yeah, I don't think you can just be, if you just have like a system where there isn't any economic feedback, then people will get into these misuse strategies, which you're interested in researching into. Did you feel that if they were more informed about the consequences of their actions, then they would normally correct that, and they wouldn't say, "Oh yes, I can see that that's a stupid, that's an inappropriate strategy. Yes, either I have the air conditioning, I close the window, or I switch off the air conditioning and open the window."
I think I'm more interested in why else do people open windows other than to just cool the room or maintain sort of a thermal comfort. That there might be other reasons like connecting with the outside space, or and where do those get modelled within these kind of systems? Because the systems do tend to look at a very sort of physiological sense of comfort.
Are you asking people? Are you asking them why?
Yeah, that's what my methodology is about, is trying to uncover why people...
Yes, but would you be asking them the question?
Of why they're doing it?
Yeah.
Sometimes in some questionnaires directly, but in others indirectly, and using a kind of language tools to uncover what the values are that they're trying to achieve.
See, it sounded as if you were critical of them opening the window, but opening the window is a natural gesture, act, and it may be positive, whatever else might be happening. I mean, if they want to open the window, let them open the window.
No, I totally agree with that.
But then, it's a legitimate question, why are you doing that? Because if you made your own assumption of why they were doing it, and in fact went a step further, as you implied that they are wrong in doing it, that you would be making a big error.
Yeah, I guess the
Because
use
you're
of the
wrong.
word misuse
Yeah.
is
Because-
confusing.
Yeah, the only way in which you would have known that they were doing the wrong thing would be if you were measuring everything in the room, including their own blood pressure and knew all their life story. So in the simple way, you would assume that they're doing the right thing, and then you would go and find out why it was the right thing that they were doing.
Yeah, I think you'd have to define misuse as meaning that they're not achieving the goal that they had, or something like that. But it's only because the occupant or the user is an unpredictable thing, or maybe you could define misuse as they actually break it, so they just smash the window, and now it's not a window anymore, now it's a hole. So the definition makes it hard to answer that.
So I think there's an interesting theme here, which is the actual building occupants participating in the process. How do we research that? That's one thing. And then if we have simulation tools, how can we factor in or particular types of behavior so that we know that the systems, that the actual physical fabric or mechanical systems can support that type of behavior. So I think there's a number of, we're throwing questions at each other in a very healthy way. I would like to see more research. Then you're saying, yes, but your design tools, your simulation tools should be more, should take into account the behavior of the occupants, I guess. That's pretty good.
It's a great discussion. Let's pick this up after lunch. We'll have 2 more sessions starting at 1:30. And so first up after the break is Kasper Jørgensen from 3XN in Denmark. So that starts at 1:30.